Hello. Okay, so we're gonna do a basic recap of chemistry basics again because now that we just did hair, so we did intro to chemistry, we did hair properties, and now we're gonna take hair properties and chemistry and put them together because you are ultimately doing chemical services on hair. So let's just kind of review the chemistry basics that you did a couple units ago. The first thing we need to talk about are elements, okay? So you have already heard of the periodic table of the elements. So this chart shows us all of the elements that there were or ever have been in the universe, okay? And all of these elements come together to make different substances. So what is an element? An element is the simplest form of chemical matter, and it's anything found on the periodic table, right? So if I'm talking about carbon, so carbon is right here. Okay, that is just one element, carbon. It's the simplest thing, okay? Can't go down any further. If I do, then I'm starting to talk about different properties within that single element, okay? So an element is the simplest form, okay? And then we have these things called atoms. Atoms are then the smallest chemical component of an element. So for instance here, I have the atom hydrogen. How do I know that? Because I have one proton inside the center of the atom and one electron, okay? I know that hydrogen has one proton, so I can identify this as the hydrogen atom. And then what we can do is we can take different elements off of the periodic table and put them together to then make this thing called a molecule. Okay, so for example, you drink water on a daily basis, or hopefully you drink water on a daily basis. Water is H2O, which means that it has two hydrogens and one oxygen, and that makes it a molecule. So a molecule is when multiple atoms come together. So examples would be water, ammonia, which you also use in the lab, which is NH3. And then you also use this stuff called hydrogen peroxide, which you mix with your hair color, which is two hydrogens and two oxygens, which makes it H2O2. Okay, so now let's talk about the different physical and chemical properties. So let's think about physical properties of ways that we describe what the chemical or the thing looks like, right? So color, is it red, yellow, green, blue, a white, black, etc. Solubility, if you remember from our intro to chemistry, solubility is whether something will dissolve in something else or not. So a solute dissolving into a solvent. Odor, whether it smells, it'll have a specific smell. The hardness of it, so diamond is the hardest, the item that has the hardest hardness, meaning we can't grind it down. Density, meaning will it float or sink depending on what it's mixed with. Or you can kind of think of it in terms of if I have a certain amount of grams of something, how much space does that stuff take up? And then what temperature does the substance melt at, and what temperature does it start to boil at? So physical properties we determine without even talking about a chemical reaction, right? So if I was to pull out some hydrogen peroxide, you can describe physical properties to it without even doing anything to it, right? You can tell me it's white, you can tell me it has a strong odor, etc. There's no chemical change in the substance, right? That is a physical property. The other thing is a chemical property, okay? So chemical properties are things where you're gonna see where we're gonna do a chemical reaction and I'm gonna go from one substance to another substance. Okay, so let's get a basic understanding here. It's when a substance are changed through a chemical reaction. So like I said before, if I just had hydrogen peroxide in my hand, I could start to talk about the physical properties of hydrogen peroxide. I can say it's white, it's a liquid, it has a strong odor, okay? But not until I mix it with hair color does it actually start to have a chemical reaction, right? Once that hair color is mixed, then you get a different odor, the color starts to change, etc. So these are three other different types of chemical properties we can talk about. Zinc reacting with acid, sulfur burning in air, and this one you're probably most familiar with, which is rusting of iron, right? Once iron rusts, you can't put it back to unrust iron. It's always rusted. Okay, so physical changes. Physical changes are just the change in the physical form of the property, right? So temporary hair color is an example of this because you're just temporarily adding a color to the hair strand that'll eventually wash off. Removing nail polish is also a physical property, right? Because the nail polish isn't chemically on the nail, you're able to remove it. So then that is just a physical change. Another physical change you can talk about is ice melting. So going from a solid to a liquid, and then if you were to boil it, a liquid to a gas, that is also a physical change. What I want you to think about when we're talking about physical changes is I am not changing the chemicals or the molecules or the elements inside of that substance, right? So when I have water, which is H2O, 2 hydrogens and 1 oxygen, when I take water from an ice cube to a liquid, I am not changing H2O. It's still water, it's just in a different state of matter, right? So it's sort of the same concept here is if I'm changing something from a solid to a liquid, I'm not changing the chemical composition of it, I'm just changing the state at which it's in. A chemical change, on the other hand, you are chemically altering the substance, right? So the image here I have is a piece of paper burning. As that paper burns, I can't go backwards and make the paper again, right? So it's the same thing like with a physical property with nail polish. I can apply the nail polish, remove it, and then I can apply more nail polish, right? That's a physical property. Chemical change or physical change. Chemical change, you cannot reverse it, right? If you ever go to a bonfire and you put wood logs onto a fire, you can't then make wood again, right? Once it's turned into ash, it stays ash. So a chemical change is a change in the chemical composition of the substance, creating a new substance, right? So when you take your hydrogen peroxide and your hair color and you mix them together, you're creating a new chemical that is going to allow you to deposit that hair color into the hair cuticle. Okay, so let's talk about a couple of different chemical changes that you see in cosmetology. One is oxidation, the other is reduction. Oxidation is when you lose things to one substance. A reduction is when you gain things from one substance, okay? So when we do a waving solution, so I'm thinking of perms, things like that. When a waving solution is added, if you remember our 3 side bonds in our hair, a disulfide bond is broken through reduction, meaning something is added in to break that bond apart. Okay, so reduction is the removal of oxygen or addition of hydrogen. So in this instance, during a waving solution, you're adding hydrogen to break that disulfide bond. So then you can alter the wave pattern of the hair. We've kind of already talked about the pH scale a little bit, but let's just do a refresher. The pH scale measures the acidity and the alkalinity, which is also known as the base. Less than 7 is an acid, more than 7 is a base or alkaline. So when you're dealing with ammonia, that's considered a base because it's greater than 7. If you drink soda, that's between a 2 and a 3 on the pH scale. Again, we've already kind of talked about the importance of pH, but just as a refresher, we increase the pH when we want to get into the cuticle to deposit something, okay? So if you're at a pH of 4, which is around here, you'll notice that the cuticle is closed off. As you start to increase the pH, the cuticle opens, right? So that's why you're mixing your hair color with hydrogen peroxide, because what ultimately hydrogen peroxide does is it opens that cuticle up so it can deposit the hair color inside of it. And then it eventually closes to keep that hair color inside of that cuticle, and that's where you get permanent hair color from. So the natural pH of hair is between 4.5 and 5.5, right? Because that's going to be where your closed cuticle is. You want your cuticle to be closed because you don't want things to be able to deposit into that cuticle and stay there. And then as you move up, you're going to have to put chemical processes onto the hair in order to open the cuticle. Again, chemical texture surfaces are things that raise the pH, right? Because in order to apply the chemical texture surface, our pH needs to be high so we can work within the cuticle to make sure the surface sticks, right? So chemical texture surfaces raise the pH of hair in order to swell the hair, open the cuticle, allowing product into the cuticle. Okay, permanent waving. Let's speak a little bit on this. Permanent waving is a physical change. You are oh, I'm sorry. You can have a physical change and a chemical change during permanent waving. The physical change is you just wrapping the hair in the perm rods before you add any chemical. You are taking the hair from its natural state to wrapping it up in a curl to a curly state. And then the chemical change piece is when you apply the permanent waving solution and neutralizer, right? Because you are now chemically altering the cuticle and the hair to give it a different wave pattern. Okay, so what I want you to kind of think about based off of what we've talked about here is kind of in your mind compare and contrast chemical changes, and if it would benefit you to include an example to kind of think about so you can tell yourself whether you understand the difference between physical and chemical changes. Thank you.